Today, we are going to be covering a number of topics. First of all, do you actually need to ditch material when you do compose? We're going to be looking at the building blocks that make up the compose framework that you might or might not be aware of. We're going to be looking at how theming works in compose. We're going to be looking at how you write a good API in compose. How do you make your composable usable for other people? We're going to be looking at how you write the custom composables, not just how you make them usable, but also how you do them. How does it work? And then we're going to have a couple of tips for you to wrap up so that maybe you learn something even if you already know everything else that I talk about. Okay, before we get started, I have a URL for you. You might want to take a picture because I am going to have a bunch of links in the talk, and there's going to be that symbol there. When you see that symbol, you find the actual link on that web page. Going to give you a minute. Less than a minute. I was lying. Sorry. I'm going to tweet the link later on my Twitter. Don't worry. You're going to find it somehow. So, material design. What is material design to you folks? Well, it is the default design system that you will encounter when you start using compose. Now, for your day-to-day life, you've probably used compose, I would hope at this point, and you have probably used the material composables in your application, in your code. For many people, in fact, when they think about compose, what they're thinking about is the material implementation of the composables. There are right now 2 material versions, let's say. The old one is V2, also known as material theming. But since Monday, we have material V3 stable for compose, which is called material U. You can find V1 right now, and you can use that. I think you should be using that version of material if you start a new application. And if you're on an old version of material, you should also think about upgrading to V3. Material is really cool. Why? Because, well, it's well documented. There's a lot of information out there. I had taken that out. OK, I didn't save, apparently, my changes to the deck. Sorry. Material.io is the only URL you should care about. M3 Material.io is the same thing right now. It used to be 2 different websites. But all the information about Material 3 is going to be on that website. You're going to find specs. You're going to find information, guidelines, all the kind of stuff you need to build a good material app. Material is also very flexible, and that's a huge thing. You can change the colors of your composables by just tweaking the material theme. You can also change the shapes that material uses, because maybe your design system has huge rounded corners, or maybe it does not have rounded corners, or maybe the designer is a fan of Battlestar Galactica, so it has cut corners. Maybe it's just a bit of a fan of Battlestar Galactica, so there's only one cut corner. You never know. And you can also change typography very easily in material. Maybe you have a sans serif font. Maybe you have that font. But while material is good enough for most people, most design systems can be retrofitted onto material. There are some limitations to what material can do. If you're only doing visual tweaks to your composables, material is still a good choice. It's a solid foundation to build upon. But there are cases where material might not be the right choice for you. For example, if you need to change the behavior of your composables, or if you have some semantics in your design system that are not compatible with the material ones. So what are other design systems? Well, the way a design system is born, 99% of the time is designer pings you on Slack, and like, hey, implement this. And you're like, wait, what? Nobody told me anything. That's fine. I'm going to take care of it. So what you get is a set of components. that you need to implement. You get information about the typography that the project is supposed to have. And then you get a bunch of colors, like a palette, that you're supposed to be using everywhere. And now you have the age-old question of, where do I start from? So the first choice you need to make is, do I want to base my design system implementation on material, or should I start from scratch? Well, that's a complicated question, and what it boils down to is my design system compatible with material? I need to take a look at what already is in material. What are the components that are already implemented? I need to look at how much I need to hammer them down to do what I need them to do. And I also need to consider the differences in the visual components and in the behavior of them. My personal recommendation is, if you can at all, you should be reusing material. There's a very good reason for that. It's battle tested. It's going to take less time, less effort. You don't have to re-implement everything. Just is generally a better choice. That said, there are cases where you're like, not going to work. So what do you do in those cases? Well, obviously, if you don't want to use material, you probably don't want to ship it in your app, because that's just inflating the APK size for no reason. Well, there's good news. While the Vue framework that we were used to using, it was a monolith, and still is a monolith, you cannot just take apart. It's one block. Compose, on the other hand, is modular. There's 4 main components to Compose. And yes, I know you're probably thinking, that looks like the Windows logo. Please pay attention. Colors are different. Well, in different order. And also, that's the Windows logo these days. So that was an important aside. Now, you can get rid of material because it's a modular system. That's great. And the way you do it is you go to your build script, you find the line that says material, and you take it out, right? That's the easy way. Now, unfortunately, sometimes you cannot just take it out. The reason for that is that there might be third-party dependencies or other dependencies you use that implement transitively material 3 or material stuff. What you can do in those cases, you can pretend it doesn't exist. So one of the things you can do is you can open the preferences in your IDE, and you can go into the exclude from auto import section, and you add the material package there, and the IDE will pretend it does not know what material is. It is still going to be shipped in the app, but it wouldn't build otherwise. But at least when you're typing stuff, it doesn't suggest material stuff to you. Now, you can find more information about this on the IntelliJ website. The web help has a lot of info on this. There's also a nice blog post about that topic that came out a few months ago that I forgot to put the link for, but I'm going to add that. OK, so we've taken out material. And of our 4 main components, we have taken material out. Awesome. One problem is that most of the composables that you were using probably were in the material package. So what do? All that stuff is in the material package. That's a problem, because you've probably used them, all of them, or most of them, in your app. And it's not just the composables. There are ripples. There are other APIs that are fairly useful that you find in material, and that you probably just got accustomed to by just doing compose. For example, local content alpha, or you also have the content color, or you have the local text style. One note, local content alpha is only material 2. So if you're upgrading to material 3, that doesn't exist anymore anyway. Just FYI. But yeah, we can still do it. We will rebuild. And there's one great ally we have to make this happen, and that is Foundation. Foundation is great, and I'm going to explain you why. So you were using that composable. You probably put some text in your app at some point. That's the material text composable. If you look at it and you command click into it, you will notice that it's actually delegating the logic, some of the logic, to basic text. And basic text is a composable that lives in the foundation package. It's one of the other 4 components. That, in turn, delegates to the layout composable. And that lives in another of the Windows colors that you were seeing earlier, which is the UI package. And that, in turn, delegates to the compose node that lives into the runtime. Now, this is a simplification. Don't yell at me for this, but that's the general idea. Now, what we have done is we have taken the top layer out, but the rest is still there. What we can do is we can create our own text composable and just delegate the rest to Foundation the same way Material does. Now, that's amazing, because that means we don't have to copy-paste textview.java and tweak it. We are never starting from scratch. We are taking the basic building blocks that are provided by Foundation, like layouts. For example, you have seen box, you have seen row, column. There are some modifiers that also live in Foundation that you do not have to re-implement. We'd also get lazy layouts for free. We don't need to recreate that stuff, thank God. So lazy row, lazy column, lazy layouts in general. And you also get a set of bare composables that are like the bare minimum implementation of something that you can then build upon to create your own theme version. For example, canvas, for example, image, all the logic and mechanisms for scrolling, interactions, and some visual stuff as well. These are the foundational concept, hence the name, Foundation, for creating and implementing a design system in Compose. Okay, Foundation is awesome. Let's get started. Now, again, Material, even if you're not using it, is a great source of reference. If you're implementing something and you don't know what to do, go and study Material. Material is going to be your gold reference implementation for anything, because at the end of the day, it's been worked on for a long time and by people that actually know what they're doing. One thing about Material, though, is that you have to remember that we've said it's very flexible. Flexibility is great when you need to customize the theme, but in your case, if you're implementing your own design system, you probably don't need as much flexibility, and thus you can reduce a lot the complexity of the implementation compared to the Material one. Only take what you need from Material. The important stuff that you need to care about are the basic concepts and some patterns that you can also apply. There are parts of Material that you will have to implement, but it's fairly easy, and we'll see how. Talking about patterns, there's a couple of patterns that I want to show you that are used in Compose and in Material that will most likely apply to your custom theme as well. First of them is composition locals. Composition locals are a way to provide values to a composition. They essentially provide an implicit dependency from your composition to some value. They're useful for data in the sense of like colors, text size, that kind of stuff. Now, if we want to see how composition local providers work and composition locals, we have a simple example here. We can see there is a composition local provider, and inside of it, we have a basic text. Now, you will notice that the basic text is referencing local content color, which is defined and then provided by the composition local provider. The way this works at runtime is that, oh, the code says that the local content color for this composable block is black. So at runtime, when you refer to local content color current value, what happens in the compose runtime is just injecting the value, the result value for you. Okay, now that we understand what composition locals are, you probably started to understand why it's such a foundational concept and why it's so important. Theming is built on top of composition locals. And composition locals are also powerful in the sense that they can be scoped to a part of a composition. You have a big set of composables, but you only want to change, say, the text color for a subset of them. What you do is you wrap that part into a composition local provider where you override just the text color. And so everything in there will have the right text color instead of having to go and set it on every single one of them. But, like every tool, it can be dangerous, and you should not overuse it. This means don't try to be too clever. Stick to the easy stuff, because it's an implicit dependency, and it's really hard to keep track of what goes where sometimes, especially if you use composition locals a lot. So try to be tidy with your usage of composition locals. Another concept that you should know about is indications. Indications, as the name suggests, indicate the state of a composable. For example, here we have a box that has a background and it's in its idle state. Now, we can bind to an interaction source, which is essentially a thing that gives you a pointer event or something like that. And maybe we're on desktop. Let's make an example on desktop. When the mouse pointer goes over your composable, the interaction source will report a hover event, and then you can have an indication that changes the color, highlights the composable that you're over. Maybe the user then clicks the composable, and then you get another event, and then your indication should darken your composable. It really depends on your design system how this works, but that's the basic idea. Now, in materials, indications are ripples. You get it for free. You can also use ripples in your own custom design system by just including the ripples dependency if you only want that from material. It's a separate thing, so you can use it. Now, indications are essentially a class that can draw behind or in front of the content, depending what you want to do. They are provided by a composition local. Again, you see the power of that mechanism. And if you want to implement your own, you can look up the default debug indication, which is a very simple implementation that, if I recall correctly, just draws a red border around your composable when it's clicked or something like that. Now, I did mention earlier that when you're building a theme, you will want to make it so that people know intuitively how to use it. There are official guidelines for Compose that you will find linked in my mini website for the talk. They're somewhat based on the Kotlin conventions, because obviously Compose is based on Kotlin, so you don't want to write weird Kotlin just because you're doing Compose. You want to write something usable. I strongly recommend that you read them, even if you're not thinking about implementing a custom design system, because even for your own custom composables that you're going to have to create for your own app, it's good to be aligned with the rest of the Compose framework. They're based on years and years of experience from the folks at Google, and they really do help with consistency, because maybe some of the principles that they explain, you will maybe intuitively understand some of them, but I guarantee some of them you have to be conscious about. And the great thing about this is that you can easily meet user expectations when it comes to using the stuff you're making. Okay, I'm going to just highlight a few of those principles from the guidelines. The first one is a fairly obvious one. When you have a composable that contains something else, you pass in the contents as a composable lambda. It's a parameter. Now, you want to be fancy, you can call them higher order functions. Now, I'm not a fancy person, so it's a function with function parameters. Now, another thing that you might have noticed in material is that when you have different variants of the same component, they are modeled separately. So you have a button, and you have an outline button, and you probably should do the same. There's a blog post on the reason why that is that I recommend reading. And another pattern that you can take inspiration from material about is the slot API. Now, there's another blog post, homework, that explains why they're very powerful. The basic idea is pretty simple. The idea is that your composable should only do one thing and should delegate all the extra stuff to other composables that your user will provide to you. You have slots for the subcomponents. You just have a place where things will go into. And if you're creating your own design system, you probably want to provide the styling and the components, the default implementation of a component, so that your user can easily get the bits they need. It's more flexible and easier to use than having implemented a different way. An example e-material would be scaffold. The scaffold has a slot for the top bar, a slot for the bottom bar, a slot for the floating action button, and more. And also, material provides a concrete top-up bar implementation, a concrete bottom navigation implementation, and a concrete floating action button implementation. Another important topic, DSLs. If you need to have scoping in your theme, DSLs are the way to go. The idea is that you have lambdas with receivers that allow you to specify exactly where functions and modifiers make sense, because not all of them make sense all the time. So they should only be applied in certain circumstances. For example, you might have a box, and a box, you will notice that the content lambda for a box has a scope of box scope, and box scope only provides a couple of modifiers, for example. Or lazy composables have a lazy list scope receiver for their lambda that also provide a bunch of functions that you might need. Okay, I think the takeaway here is that great artists steal, as someone once said, more than once. You should use material as a reference. It's a great, great source for ideas and concepts and even implementation. The basics are probably going to be mostly the same that you have in your design system. Is the difference will be elsewhere most likely. Copy-pasting stuff is fine, I swear. Nobody's going to come after you if you copy-paste a bit of material and then change it to suit your needs. If you see something that you like in material, mine. Obviously, when you do copy-paste, like everything, you should simplify things whenever you can. Complexity is not necessarily good. Copy the patterns as well. That's very important. For example, material uses the color.unspecified when you are able to pass a override color for something, but no, as the default value is unspecified, so it says, okay, there's no override, I'm just going to use the default that comes from the theme. If you're not going to need it, don't take it. You will not need all of material. It depends on the actual design system you're implementing, which parts you need. An example can be indication. Say you have a button, and that button, when you click it, it just goes down. Now, you don't need an indication for that because the button will have that logic itself. Consider instead that you might need an indication for things like focus and hover, especially if you're doing desktop stuff. Okay, making composables. How do we do that? Let's pretend I work at Duolingo. Pretend I do not work at Duolingo. Let's make it very clear. Now, why? Because I use Duolingo, I really like their design system, and it's very custom. It's probably a case where I would go with a custom design system. And let's say I got my message from the designer, and I have to implement the button. They send me the specs, and I look at them, and it's like, okay, what is a button? I know, I got philosophical there for a second, but there's a reason for that. If you look at the spec, you will see that you have a thing that has different states. Okay, maybe you have a normal state, a press state, disabled, other states, whatever. But what is that thing that you're seeing in the specs? It's something that you can click. And this is the mindset you need to have when you're implementing a custom composable. And then the mindset should also be, okay, how does it work in material? How did they implement it? Well, if you go and look at the code for the button in material, that's what it looks like. It's a surface with an on-click thing. Good. Surface is a box. It's a box. It's a fancy box. And if you add a clickable to a box, you essentially have a button. Now, you don't have a surface in your code if you have taken out material, but you do have box. So if I wanted to implement my own button, I would do it like this, like my Duolingo button. First of all, I would take a box. That's what I get. That's fine. Then I would say, okay, clickable, button, clickable, makes sense. Obvious. And inside of there, I do provide stuff like the color for the content and other styling parts. Then I also need to set the text style so that whatever the user passes in as text is automatically styled the right way. And then, Instead of there, I put a row where I will just dump the content that the user passes me. I do need to set the background, and I do need to set the content. Okay, button, that was easy, fine. Let's do something more difficult, text. Everyone knows text is hard. Text can be extremely hard. There's layout of the text, there's shaping, there's rendering. If you don't know what shaping is, bless your heart. There's emojis, there's fonts, there's bidirectional text. It's a lot. What if Compose made that easy? What if? Well, it is. You just take basic text. We have seen that earlier in the example of the text composable. If you take the text composable from material, well, that is basic text plus some logic to set the styling. So that's what the text composable looks like in material. And guess what? That's what our text composable will look like. We have a few lines of code to define the styling, and we throw it to basic text and like, off you go. Done. Okay. I was lying earlier, I said text is hard. It's not that hard. Well, maybe when it's editable. Like, editable text is more complicated because it's dynamic. You have to deal with selection, cursor, the clipboard, maybe other ways of inputting text. It is much harder to do in Compose, honestly. No, it's not. Okay, so you will sense a pattern here. There is basic text field. It's another composable that lives in Foundation. And again, it's the same thing. You just define your styling and pass it to the basic text field, and you're done. The one thing you need to consider, though, in the case of text field, is that you only get the bare place where you can type, but you have to implement your own decoration and box. For example, you might want to have an underline, like Material does. Maybe you want to have a box. Maybe you want to have a background, an icon, whatever. That stuff you have to provide yourself. But the difficult part, which is handling the editable text, is done for you. One last example, a progress bar. Now, a progress bar is one of the cases where Foundation will not help, because there is no built-in composable for progress bar in Foundation. And you might start thinking, oh, no, not again. I have to implement everything from scratch. Okay, let's see how Material does it. Let's go low level. Let's start command clicking like there's no tomorrow. So it turns out that the way Material does it is it draws to the canvas directly. Don't get scared. It's not that hard. It's pretty easy, in fact. The only thing you need to remember when you're dealing with a progress bar is that right to left and left to right directions that the user locale dictates needs to be respected. So your progress bar might go this way or that way, depending on the user locale. Let's look at how a progress bar looks in Duolingo. Well, like any progress bar, there's a track. Then there is a bar, the famous bar of progress bar. And then they're also a bit fancy. They have a highlight on that bar to make it look more nice, cartoony. That's okay. The Material one doesn't have the highlight stuff, but the basic idea is that it's a canvas composable. That is a way you can draw to the canvas, obviously. And there's a few modifiers that are useful for us, and then essentially there's two calls, one that draws the background and one that draws the bar. That's fairly easy, right? So if I were to create my own progress bar, what I would do is I would put a canvas composable. I would put a progress semantics. That's very important for accessibility. I haven't shown it in previous examples, but accessibility is important. Do pass accessibility semantics to your composable. We'll get back to that in a second. We're telling Compose, oh, I'm a progress bar. And then we cheat. And the reason why I say we cheat is that you look at the progress bar, it's nice, it's rounded, it's colorful. What happens when it's shortened? So if it's short enough, you will notice, for example, the highlight disappears because there's no space to draw it. There's a margin on both sides that you need to respect. That's easy to do. We just don't draw when the bar is short enough. What happens if the bar is even shorter? It can get to the point where it's essentially the bar is a circle. And if you go any shorter than that, you get that thing that sucks. The reason for that is that if you're drawing a rounded rectangle and it's shorter on one dimension than the radius, then the radius gets scaled down, so you get still a rounded rectangle and not a nightmare, I guess. I don't know. Anyway, we can fix that. Let's go back to the base case. Now, we can say, OK, let's just take the track and clip to it, because our bar is never going to draw outside of those bounds. Cool. And now we start drawing the progress bar outside of the actual track clip that we've just defined. This way, it's always going to be rounded the right way. Now, we just move 2 radii to the left or to the right, depending on the direction of the layout. And then when the bar grows, what the user sees is the actual correct rounded bit that comes in. And then it will look correct. That was the cheat. Now, we draw the track. Now, we've just applied a clip with a rounded corner, so we don't need to draw a rounded rectangle. We can draw a normal rectangle. We have our logic to update the size of the actual progress bar. We draw the progress bar. We've just seen how. We define, check if there is a highlight and where it's located, and if it exists, we draw it. OK, almost there. Important thing, again, cut corners when you can. Do not overcomplicate things. If you look at the button composable in material, it takes in, I don't even know how many parameters. But if you don't need them, drop them. Just take the stuff that you actually need to be able to customize in your design system, and the rest can go away. For example, if you want to be only as flexible as you need, things that you might want to drop for the Duolingo design system, you don't need shapes. Everything has the same shape. It's always the rounded rectangle, always with the same radius. Easy. So what you can do is you can just hard-code those shapes instead. And again, don't forget, layout direction is important. It will change the way things look, especially in an app like Duolingo, where people from all over the world are going to use it. You have to be conscious about layout direction. Lastly, accessibility. Never forget accessibility. I'm going to stress that. It is not a corner you can cut. Accessibility in Compose is all about semantics. You just need to apply semantics to something. In the vast majority of cases, that will do the job. It's one line of code. Please, don't forget to do that. You only need to tell Compose what the role is of your composable. You can tell it it's a button, it's a progress bar, it's a checkbox, it's a switch. It doesn't matter. Whatever it is, tell it to Compose, because then Compose will tell it to a screen reader. And it's easy to see if you've done it right, because if you turn on Talkback and you start using your app, you're going to see that you close your eyes and you can actually navigate through it just by swiping. Think about that. It's very important. There is a lot of documentation on the topic. There are talks from I/O and from other conferences that you can refer to. Please do not forget accessibility. Recap, what we learned today. Study material. It is a great source of learning. Second thing, use Foundation if you do have your own custom design system. It's going to make your life 1,000,000 times easier. Third thing, be efficient. Only do the things that you need when you need them. Fourth thing, if you need to cheat and you can cheat, do cheat. It's graphics. It's all smoke and mirrors most of the time. And then lastly, wrong one. Use established patterns. So if you see that something works, don't reinvent the wheel. It works and people are used to it. It will make sense to them intuitively. That's great. It's a value. It's not a bad thing that you didn't do things your own way. Be consistent with what's out there. And with that, any questions?